Next is mathematical reasoning. Just like language, mathematical reasoning also have reasoning and rules that you have to follow to make sense and avoid fallacies. To simply put it, mathematical reasoning is a method at which people can tackle a problem. This is when a person takes the data, extrapolate and analyze the data on hand, and try to find the best way to find and execute the solution. Although there are seven total ways of solving a problem: initiation, counterfactual thinking, critical thinking, backward indication, inductive reasoning, deductive reasoning, abductive induction. Only two are the most well known amongst them, which is inductive and deductive reasoning. Inductive reasoning, a type of reasoning that stems from understanding patterns and making a prediction from your analysis of those patterns to reach a general conclusion. This general conclusion is unproven and is called a hypothesis. An example of inductive reasoning could be the Fibonacci sequence. When you add 1 to the previous number and keep the cycling going, that being 1, 1, 2, 3, 5, 8, 13, 21, and so on, then through inductive reasoning, you will get the Fibonacci sequence. There are multiple types of inductive reasonings. Number one is generalization. This is when your inference towards a majority is rooted from your observation of a small group of people. An example of this is we can see that geese attack people through the internet videos. So, all geese will attack you if you get too near. Second one is the statistic induction. By using a statistical method of analyzing a population or event, you can draw your conclusion from the data you collected. An example is, out of 100 customers, 30 bought bread. So 30% of the customers only want bread. A variation of this is the Bayesian induction. This is similar to the statistic induction, but it adds specific details to make the conclusion much more accurate. Example: out of 100 customers who bought the bread, 30 brought pan de sal with choco filling. So 30% of the customers want pan de sal with choco. The next one is causal inference. Arguably the simplest type of inductive reasoning, the conclusion drawn is typically rather shallow or obvious. An example is, there is a typhoon today, so schools will more likely than not be closed tomorrow. Next, analogical induction. This is when you take similar features and qualities of your subjects and events and draw a conclusion to form a relation between them based on those similarities. An example is, fans and helicopter propellers both have fins, therefore, they both work with the same mechanisms to blow air. The last is predictive induction. As the name suggests, you form a conclusion by predicting future events based on past occurrences. An example is, students gave Taylor an A in his test. So if Sammy also studies for the next test, then he will also be given an A. The next type of reasoning is deductive reasoning, a type of reasoning that stems from following a set of rules to form your conclusion. And if both hypothesis and conclusion are found to be true, then you can say that the conclusion is true. An example of a use for deductive reasoning is research papers that are solidly based on facts with little to no assumptions. If the hypothesis is true, then the results are true. Then the conclusion is true. For an everyday example, here's one. Hypothesis is tunas have gills, so it is a type of fish. Conclusion: fishes have gills, so tunas are also a type of fish. As long as both hypothesis and conclusion are true, then the entire statement is true. And though there are 5 types of deductive reasonings. The first one is the hypothetical syllogism. This is when you connect two or more statements together by their respective facts. Example: A is equals to B. B is equals to C. Therefore, A is equals to C. Disjunctive syllogism. When choosing between two statements, if one is proven false, always take the other. Example: if it is either A or B. But A is false, therefore you choose B. Next one is modus ponens. If a truth statement implies another, then the implied statement is also true. Because this is an example of this is A is equals to B. If A is true, then therefore B is also true. Same as goes to the opposite, which is modus tollens. If a similar, it is similar to modus ponens, as I said, but this time it's for false statements. An example is A is equals to B. But A is proven to be false, therefore B is false. The last one is simplification. If two connected scenarios are found to be true, then each scenario can be stated as true. Simple enough. An example is both A and B are true, so A is true. Another example is it's true that today is both raining and freezing, so it means that today is raining. But of course, we should be careful with how we use these deductive reasonings, because we might fall for fallacies. There are 3 types. One is fallacy of affirming the conclusion. For you to know if the conclusion is true, you must know that your hypothesis is true, not the other way around. To explain this, if A equals to B and B is true, therefore A should also be true, is not a sound reasoning. You don't know if A is true, so why assume if B is true if the true value is based on A? The second fallacy is fallacy of denying the hypothesis. There are also times where the conclusion isn't solely based on the hypothesis due to the fact that there may be other outside factors in play. An example is if A equals to B and A is false, then B should also be false. Isn't a sound reasoning either, because there are other factors outside of A that could lead to B being true, since A is only one of those factors, not the only one. The last one is begging the question. Similar to fallacy of affirming the conclusion, this statement is when these statement proof relies on the fact that the conclusion is true, then the reasoning isn't going to be sound. Example is A is equals to A, but A is true, so A is true. It doesn't make any sense. Since how are you going to assume the validity of your proof if the proof itself is based on the conclusion? Doesn't make sense, does it? Of course, what is the use of reasoning if there is no way of proving its validity? And this is where methods of proof comes in. The first is vacuous proof. It is proof that the implication of P is to Q is true because based on the fact that P is false. Second is trivial proof. Implication of P is to, if P then Q is true because of the fact that Q is true. Direct proof is the implication P then Q is true because showing that Q must be true if P is true. Indirect proof is the implication if P then Q is true by showing that P must be false when Q is false. Proof by contradiction. A proof that the proposition P is true based on the truth of the implication, not P is equals to Q, where Q is a contradiction. Proof by case. A proof of an implication where the hypothesis is a disjunction of propositions showing that each proposition sparingly implies the conclusion. Next is the existence proof. A proof of a proposition of the form reverse EXP X. Classified under two distinctions. The first one is constructive existence. It essentially states that it establishes the assertion by exhibiting a value C such as C is true. Non-constructive existence establishes the assertion without indicating how to find a value x such that Px is true. It commonly involves a proof by contradiction. The next is non-existent proof. A proof of statement not reverse E X P X. One way to assume that there is a number in the universe of this course for which Px is true and try to arrive at that conclusion, the contradiction. The last one is proof by mathematical induction. Let Pn be a proposition for which positive integer n. If the following two contradictions are satisfied, then Pn is true for all positive integers n. The proposition P1 is true. The implication Pn then Pn plus 1 is shown to be true for every positive integer n. Thank you.